x mu is t x y z, okay, or the time and space coordinates. Now we want to generalize it further, and this goes to x mu sigma alpha, and if you like, so these would then be, these are called as string coordinates or the string fields and their canonical moment. Now you see here x mu was a generalization of t to the to include x, y, z and t, time and space, all the variables. Okay, here, and this is a field. So this actually sigma alpha itself is a field, and x mu also is a field. Okay, so now I think your point will become clear once we write down let us say what happens in our relativistic point particle action was proportional to length, right? And here when we generalize it, this is minus t times d in the area. Here it was proportional to the length of the word line. Here it is proportional to the area of the word sheet. This parameter in the point particle case turned out to be the mass. Here this turns out to be the string tension. Okay, and one can write ds square minus eta mu dx mu. Now I can write it as minus eta mu dx mu d sigma alpha dx mu d sigma beta d sigma alpha d sigma beta. Now I can define this object as g alpha beta, and then I can write it as minus g alpha beta d sigma beta, but you might recollect that this was equal to minus eta mu nu Matthew, I am just trying to come close to your question that you have asked. You probably realize that. So the same ds square or this differential element of the area dA, I am trying to write in two different ways. So you see, this is originally, so d eta mu nu measures the distances in the space-time or the target space-time, whereas this object g alpha beta, this is also a metric tensor and it measures distances in the worldsheet space. And there is a special name for this, it is called as the induced metric on the worldsheet. Why is it called a induced metric? It is called a induced metric because it is defined in terms of eta mu nu. It is in turn, it is determined by eta mu nu. All right. So eta mu nu is a measure of distances in the target space or the ambient space time or the background space time, whereas g alpha beta is a measure of distances in the worldsheet space. Is this point clear to everybody. Sarah, is that okay? Yes? Lambert? Knocknist?
think so.
Yeah, we can knock diskutieren, kein Problem.
So sigma is
So,
dependent on tau and another complex field.
which one? So what is happening? Let us consider two separate spaces, and we embed one space into the other. That is what is happening. Through how this embedding is achieved, it is achieved through these string fields x mu, because they are functions of sigma alpha, which means they are functions of tau and sigma. So my string is going to be described by tau and sigma. It is parameterized by, you see here, this was parameterized by tau, and x mu tau represented embedding of this word line into the target space or the space time. Here, now this is x mu of tau